root function, we can see immediately that our solution is going to have to be greater than or equal to 0, at least, right? And again, that's just simply because the range of the square root function, real valued, is always going to be non-negative. And we have the sum of a square root. This is a square root expression. This is a square root expression, so their sum must be positive. But we can say more. And in fact, this is something that we'll be using to actually check our result. If this expression has solutions, the solution has to be greater than or equal to 1. There's no doubt about that. This condition right here, x greater than or equal to 1, satisfies this, and it also simultaneously satisfies this, okay? So x would be greater than or equal to 0 if these weren't shifted square root expressions, but they are shifted, and so the solutions have to be positive, and again, we can say more, our solution has to be greater than or equal to 1, okay? Now, this is fairly routine. It's slightly tedious, but if we call this very first part here, we'll call it A if you want to, just to see the structure here, and then we'll call this part B. All right, well, squaring the left-hand side and the right-hand side, this part right here would be your A squared, right? And then this piece right here would be your, let me go ahead and put the plus in between if you want to. This piece right here would be your plus 2ab. This entire, and also properties of radicals come into play there. Okay. And then finally, right over here, we would have a plus b squared. Like that. Okay. And of course, we squared the right-hand side to get x squared. Okay. Now let's keep moving here. Collecting like terms. Now I'm not going to go through each. You guys can just check it yourself. I double checked. I'm pretty sure I got it all right. Notice you have 4x squared here, and you have x squared here. That's 5x squared. And so when you take that away from x squared, you get the minus 4x squared you see right here. Now I just wrote this out just for the sake of you tracking what I was doing. You have 8 over 9 plus 4, which is 44. And then, excuse me, 4 is what, 11 or 44 over 11. So I'm sorry, 34 is 36 over 9, and 36 over 9 plus 8 is the 44 you see right here. Okay. All right. Now, if you divide by 4, that's all I did on this very next step. I divided by 4 to make things a little easier. Notice there was a 4 present right here. All of these are multiples of 4, and so this is what you end up with again. Now we still have a radical, so we have to square again. We have to square again. All right, and it's all fairly self-explanatory. Y'all notice the x to the 4th terms. There's an x to the 4th term right here, and then in this expansion you would have an x to the 4th term. So they cancel, and that's why you don't see an x to the 4th term right here. Okay, now we're at this point. Now, what does that end up doing here, folks? Let's see. If you add 22 over 9x squared to this side, you would get 5x squared right here. Okay, 5x squared. Okay, now if you take the constant to the other side, and I'll just go ahead and omit the detailed arithmetic. You end up getting 49 over 81. And you guys can verify that. Again, I've double checked it, but I don't want to clutter it up too much. We're going through a lot of arithmetic. All right, so we get this. Let me get some space here, folks. So that's 49 over 81 right there. Okay, and then if you divide by 5, you end up with x squared. Let's see, what do we got here? We have x squared is equal to 49. Whoops, over, what do we have right here? X squared, 5 squared, divide by 5. Divide by 5, folks. And again, I'll just write the step down. You'll end up with x squared is equal to 49 over 45. Okay, 49 over 45. You know, I'm just double checking while I'm writing it down. Let's see. Yeah, that looks right. If you divide through by 5, you end up with this expression right here, x squared is equal to 49 over 45. Okay? Now, let's see, what else do we need to do here? Well, we're getting pretty close to the finish line. We can take the plus or minus square roots right here, folks. So you would get x equals 2 plus or minus. Now, you'll find out we're going to reject the negative solution for what we mentioned at the beginning of the video, but you'll get x is equal to plus or minus, okay, 7 upstairs, right? Square root of 49 is 7. That's easy enough. Okay. Now, downstairs, this is 9 times 5, right? So you can take the square root of 9 and get 3, so you will get 3 root 5 right here. Now, y'all, that's a perfectly fine answer, but it's a very common practice to get rid of this radical in the denominator by multiplying top and bottom by root 5. Some people call that rationalizing the denominator. Now, I'm going to drop the negative solution for the reasons we mentioned earlier in the video, but if you rationalize this expression, you end up with 7 root 5. Over 15, right? Now, just taking a quick glance at this, you're going, is this greater than 1? Is this greater than 1, right? Remember our original analysis, the solution domain has to be a number greater than or equal to 1, just because the range of a square root function is positive, and then this piece right here forces it to be greater than 1, greater than or equal to 1. And so we have to be greater than or equal to 1. And if you just take a look at this without a calculator or anything, you're going, 7 over 15 is less than 1/2, right? 7 over 15 is less than 1/2. This is greater than 2, so what's going on here? But we kind of catch a break right here. We don't have to do too much heavy lifting here. Notice that this is just equal to, if you take the 7 inside the radical, it becomes a 49, right? The square root of 7 squared is 7. And so this would be root 245. And y'all, we're just checking to make sure the number satisfies the solution domain, if you choose to call it that. And then again, the square root of 225 is 15, right? Kind of nice without a calculator, isn't it? Okay, and so that's definitely, y'all, let me erase that miserable looking 5 right there. Okay, let's get back. Okay, so that would be 5 right there, and that's certainly greater than 1, right? Okay, y'all, so we've got our solution here. This irrational number 7 root 5 over 15 is the solution. Hope you enjoyed it.